Hello everyone. Can you hear me? Can you see me? You can just write in the chat box so that I know that you do hear me and you do see me. Yes? Okay, these are good. Okay, so let me go to the promotions a little and then I'll just take some of your time. So okay, so you know Unacademy Champions League is back and it gives you a good opportunity to win all the prizes, and moreover what I feel is that it really is a good thing to practice among your peers, practice with the people who are going to be your rivals in a true healthy sense, develop the sportsmanship, and then come as a winner. So that is, you see, this is 25 questions and 1 to 2 p.m. group stage, and then you've got finals also. So next slide is about the scholarships, ranks, and prizes. There are the details. You can check the details later. Unacademy Champions League, participate and win. Then you also have got this duration of 24 months and 18 months. All these things you can check. And all starts, crash course batch starts for 11 JEE Main Advanced. And similarly, educators are there. Then you have rapid revision batch. Then you have what revision batch and whatnot, integer bonanza. I mean that it's all raining prizes, and also all the courses are being launched. You also have daily practice paper for JEE Main Advanced, Monday to Thursday at 6:30 p.m. Don't forget to take the exam, enroll yourself. For the benefit of those who might not be so frequent on the channel, here is my brief introduction. So I'm Alok Kumar and I'm a BTech from IT Kanpur, and then other things you can just check out later, these things. And then welcome to my AHA lectures, and my classes are going on. If you wish to join, you can join using the code ALOKSIRLIVE, and you can avail discount also. Let me now come back to the session, and here we really start. So before I start, let me just tell you one thing, that today's session is going to be on vector and 3D, and this is one of the topics. This vector and 3D is one of the topics which is very, very scoring. I mean, you will find that entire 20 years or so till the time this vector and 3D have been in existence, they have always asked questions which are based on kind of just 2-3 topics, because you don't have much more topic, right? And moreover, vectors, some part of it you do in physics also, namely dot and cross product, and so those ideas are already common. Okay, so I would say that you develop some intuition about it. Vector and 3D. 3D consists of just 2 chapters, a straight line and plane. If you discount the basics, I mean direction, ratio, direction, cosines. So these really are a start thing. Okay, so now I'll say that we'll start and we'll do by different methods. So I have selected previous year questions because JEE Mains is upon us, maybe it in Feb, and so it's high time that you solved all the problems previous year papers. And I have selected the most beautiful questions, and it really is good that you can have practice on so many things. So let me start from the first one, and I will comment, and I will also say you that okay, what kind of thing you require for each of them. So our first question reads that if for A positive, the feet of perpendiculars from the points A and B, some points given on the plane, are points C and D. So these are something given. You want length of line segment CD. Do make a diagram always. So my diagram look like this. This is one plane that happens to be LX plus MY plus NG equal to 0. And then you have got 2 points, say A and B points. Point A happens to be A, negative 2, 8, 3, and point B happens to be 0, 4, 5. So B is completely known, but A is only in terms of a small a, some variable. And then you have got projections. So from A you are projecting this C and D, feet of perpendiculars. So they are feet of perpendiculars. So let me denote by 90 so that you understand this is notation. A and B is there. They are calling it C and D, and C form is given. C is 0, negative and negative 1, and D is not given. D, of course, like you have to find D, and your job is to find CD. I'll tell two methods for it. It really is a beautiful problem. It is one of the most beautiful problem or most challenging that has ever been asked, and you will find different themes on it. I will again connect with this number 1 with number 4. Really interesting. So things are not given directly, rather much indirectly, and someone who is doing for the first time, he will really appreciate this question, and tells you so many things. Okay, so first method is this, that what I do, that I first try to find the plane. You see, forget 0, 4, 5. It is outside the plane. It is some other point. We don't know. It's just a single point, right? We don't have much to do with it. So the most relevant information is this one: Lx plus 1 plus Ng is 0, but Lmn we do not know. So don't assume something, right? This 0 tells you some good thing. 0 tells you the great thing, that in fact origin lies in the plane, right? That we'll make use of. That's the only thing that tells you. Others we don't care. So I can look at this plane as a plane passing through point C, and normal is CA, right? I can write normal in terms of A. So this AC has direction ratios. That's just subtract. So this is A, and this is negative A, and this is 4. So A negative A4, that is the direction ratios of the line AC normal to the plane, and it also passes through 0 minus A1. Using only these two pieces of information, I can write the plane of this plane pi. I can write. Let's write this plane pi. So we are attacking one by one. So that plane pi is given by normal, or we know. So this is AX minus AY and plus 4G, and it passes through 0, negative and negative 1. That tells you that you are getting A square. You are getting A square minus 4. We really have made good use of that. So what we did here, that given point alpha, beta, gamma through which the plane passes, and direction issues are A, B, and C, we have just used that AX plus BY plus CZ is A times alpha, B times beta, plus C times gamma. I mean the equation of a plane passing through a point and normal given. In terms of course A is not known. Now the moment you apply the condition that this is 0, don't equate LM and other thing. They're just waste of time. Now the only good thing that comes out of this is that origin lies in the plane. That's marvelous. Origin lies in the plane. So I mean I can put on this side everything, and so I will get 0 equals A square minus 4, thereby giving me first victory. A is 2, A is negative 2, and because they said A is positive, I discard that, so A is 2 positive. Things are almost done. So now my plane has already come. Really beautiful problem. Now my plane has come. So let me decode what I wrote, and let me change the page. So this is 2, A is 2, so 2 minus 2, 4. So I mean that you have now the plane, and this plane normal we know. So this normal we know. So this is 2 minus 2. Let us check. We know 2 minus 2 and 4 because A was 2. 2 minus 2 and 4 normal. I can also write this normal is equivalent to 1, minus 1 and 2. And equation, I can write equation also, that is x minus 2y plus 2z equal to 0. Lmn could be anything, right? So we don't care about that. So this is, now we have got this normal. This A point is now known. A point is known because A is known. So now A point was A minus 2A 3. So you get 2, negative 4 and 3. So you get 2, negative 4 and 3. And point B was already given. B was given. And this B was the point B was 0, 4, 5. So this is 0, 4, 5. And we know this, we know now. Now we know this C we know because it was given in terms of A. A is 2, so 0, negative 2 and negative 1. So we get 0, negative 2 and negative 1. And D we do not know. First method could be, that's little long. That's not very interesting. I mean that's good, but the point is that the second is just the aha solution. So first method is that determine D. Like everything we know, we determine D. Once we determine D, determine D point, then CD is known by distance formula. So D I can determine. I can say that okay, this is 0, 4 and 5. So any point on this line is given by x minus 0 upon 1, y minus 4 upon negative 1, and g minus 2 upon 2, g minus 5 upon this one, g minus 5 upon 2, and this we can take as t. So you get t, you get negative t plus 4, you get 2t plus 5, this you get, this is the point. So this is your suppose d, this is suppose your d. Now you can put this d here, right, because this lies on this plane. In fact, you want this point, so you can put this t here, and then you should get some value of t, right? So let's check our work. So you are getting t, and then here, so this is t plus 2t, and this is minus 8 and plus 4t and plus 10 equals 0. So you get 70 is something, right? So we get 70. Let's check the work, that what we really get, because we have to get the calculation correct. So let me check the work once, that we are getting 0, 2 and negative 1. So we get 0, minus 2, minus 1, and this is 2, minus 4, 3, that's all right. And then you get 0, 4 and 5, so 0, 4 and 5, and then you are having these points. So this is your x minus 0 upon 1, y minus 4 upon negative 1, and then g minus 5 upon 2 equals t. So you are getting t and minus t plus 4 and 2t plus 5. So it lies on this plane. So t plus 2t minus 8 and plus 4, t and plus 10 is 0. So we will find t from here. So some t will come. Just check the work, just check the calculation once. So you will get some t here, right? Once you get the t, then you can find, then d is known, because d is t plus 0 and something, right? So you can check and just check later on that because I would not like to waste your time. The calculation that I got was that d did happen to be negative 1, 5 and 3. So this was the value of t, negative 1, 5 and 3. So this is your d. Just check that you are getting the same thing from here. You can check that if you want. So t plus 2t, because then it corresponds to t equal to that's satisfying. T equal to negative 1 if you put here, then it does give you that one, t equal to negative 1. So you just have to make sure that this is correct. So this is t and this is minus t plus 4 and this is 2t plus 5, and you are putting here, and so you should get some answer. So negative 1, 5, 3. Once you get negative 1, 5 and 3, negative 1, 5 and 3 d, then cd is obtained. Now cd becomes the square root of 1 squared plus 7 squared and plus 4 squared, and so you get 1 plus 49 and plus 16. So you got square root of 66, and that is one of the options. That is one of the options here. So so B will be correct, because you get square root of 66. That's a good method. It tells you at least two good things, that how to find equation of plane, and also how to find foot of perpendicular. You can directly also find foot of perpendicular by using the result. So you got foot of perpendicular. The second method, which I will again do for other problems, second method is that don't find d, avoid finding d. A is known, A is known, B is known, and plane is known. So can we do something about it? So it turns out that we can. So let me do it on next page. Let me add the page rather. So now the point is that you have got the plane. So this plane is x minus 2y plus 2g. X minus 2y plus 2g is 0. Just check this plane once, that this is the plane that you get, x minus 2y plus 2g. Correct? Just check it once, that all of you are getting this plane or not. We got the direction ratio, so let me check once from here that what I got. Here I got this one. Here I got that one, and one page is missing. Okay, so we got this one here. So we got a is 2 minus 2, 4, and so I wrote here, yeah, I wrote here 2 minus 2, 4. So that was 1, negative 1 and 2. Oh, 1, negative 1 and 2, that's what we noted. So 1, negative and 2, so this would be x plus, this would be x and minus y plus 2g is 0. We should get like this, x minus y. That explains that you can get here now answer. So x minus y plus 2g is 0. So let me write this one. So we get x minus y plus 2g is 0. Just check once more. X minus y plus 2g is 0. That is we get. Here you have got a, here you have got b, and A coordinates are now 2, -4 and 3. So A coordinates are 2, -4 and 3, and B coordinates are 0, 4 and 5. So that is 0, 4 and 5. Now you want this one, so what I will do, I'll take projection. So I'll say that, okay, this is just perpendicular, you draw this one. So if I resolve AB along this one, which will this is 1, -1 and 2. This is AHA solution, 1, -1 and 2. So if this is, call it n. So if I write AB dot n, and over mod n, if I write this one, then I am getting this one I'm getting, right? And I want this one, so I will say that this is LS square minus this square. This will be my answer, because suppose L is AB. So AB is known. Vector AB, any direction we can take, does not matter. So I'll take 2, -4, 3. So this is 2 and -8, and this is -2. This is your AB. I'm avoiding I, J, and K. So you can write AB dot n. So AB dot n upon modulus n and subtract LS squared. So you will directly get the answer of CD. So this is a short method also, and moreover you use projection, and you did not have to do the finding of D. That was of course this one that we have to do. Unless you need to find D in some problems, you cannot do this, right? So that is all right. This you can do. So I hope it is clear. Let me go to the next one. So these two methods are really good. Now this is easy one. A variable plane passes through a fixed point. The only thing, it takes long time to read. So fixed point, it passes through a fixed point. So the question says that there is a variable plane and it meets x, y, g axis. So there is a variable plane who comes like this, and it meets x, y, and g axis. I will choose my x to be here, my y here, and my g here. So I mean this is A, B, and C. And so you are writing that x over A plus y over B plus g over C equal to 1. And this passes through 3 to 1. So 3 over A plus 2 over B plus 1 over C equal to 1. This is a constraint. This is A 0, 0. So you are saying that now consider the plane drawn parallel to GX plane through B and parallel to YG plane through A. So YG plane through A. So you are drawing one plane like this, YG plane through A. Similarly. So this plane is nothing but simply x equal to A. So your planes are x equal to A, y equal to B, g equal to C. And you want locus of these planes. So if you want locus of these planes, then of course you want these points only are the points. These are points. I can consider alpha, beta, gamma also, but these are the points you want. And so locus is right in front of your eyes. So the locus of point ABC is this one. That is right in terms of x, y, and g. So you will get here 3 over x. It's just a matter of writing correctly. 3 over x, 2 over y, 1 over g equal to 1. And so we'll get that this is the locus of the point. So you will get this one. This was a fast one. This I just love. I will tell you two methods for this also. Let A is I plus G plus K. I have collected 20 problems so that you can I will solve maybe 10, and you can solve another 10 just to have some practice. I will of course give you the answer for all of them, right? So this is A and C given. You want to find vector B such that A cross B is C and A dot B is 3. I mean that you have to find then the solution of this vector equation, right? It's vector equation. So what I do, that one method is this, that I do like this, that if I know vector, so what more we can think of, that can we write something like vector A. Here vector V is there, B I want vector B. So I will resolve vector B along A and perpendicular to A, like that. I will avoid deriving it, right? I will just say that, okay, this is how we do it. So this is B. So vector B I can write as B dot A over A square times A. That is your along A, B dot A. And then one more thing will come, that I can write as B cross A over A square. See, this is the component of B. I'm just writing B. This is the component of B perpendicular to A, and this is the component of B parallel to A. So it is composed of that. This is B cross. It's just an identity. If everything you do, it will cancel. So it is an identity, beautiful identity. This one, just the geometric meaning of it, that B is parallel. Now this gives you a very good thing. You can immediately solve for B. So B equals B dot A. Now B is, I will write B now. B dot A is given, B dot A given to be 3, so this is 3, and A square is 3 because 1 is square, 3 square times A, and plus this is 1 by 3, and B cross A is given to be C, which is known. So 1/3 and C cross A, that is your answer, right? You know B, just C cross will determine. So your C, I will write like this, C is now 0, 1, and -1, and A is 1, 1, and 1. So C cross A I find by some kind of Soule's rule, and so C cross A I will quickly find as 1 times 1 minus this one, the last two columns. So that is 2, and then from here -1, 2 -1, 2 -1, and then we get 0 minus 1, so -1. So I can write -2, 1, 1. This is I have to write 2 minus 1 only because it is vector. So C cross A, right? B is this one. So it means I get A, and A is 1, 1, 1. So I get 1, 1, 1 plus 1/3 of, and 2 -1, -1. This we are getting. Just check this work first that we are getting this one, 2 by 3. So you will get here 5/3, 5/3. Then you are getting 2/3, and then you are getting 2/3. So this is the vector B. So once you get vector B, you want modulus of B. So modulus of you can quickly check, right? Because once B is here, then modulus B is 1/3 will be out, and you have got 5 square plus 2 square plus 2 square. So 1/3, and you are getting square root of 33. You can take 3 inside, so 33/9, and gives you 11/3. So I mean you solved for B and you get directly modulus of B. That is one method. This is good. You have actually solved. You have actually solved only. So this is your first solution. This is your first solution. Your second solution will be really interesting. Second solution is like this. That I'll add a page. So in second solution, I will not determine B. Just like in the problem one, I did not determine D for the second part, right? I just determined. I got directly the projection, right? And first method was that I got D actually, I got the point only. Similarly here, that one is that I got the vector B, so everything is done, I have solved it only. It's like vector equation, I solved for B. Enough information is there. Other is that I will not solve, I'll just get it. So already it is given that A dot B is 3, this 3 is given, and A cross B is C, that C also is known. So just write this as AB cos theta is 3, and AB, this will be faster, and AB sin theta is modulus of C, and modulus of C is given, right? C is a given vector, that we know, C is given vector, so modulus is √2. So I write this as √2. This is 3 by √2. So it means I get tan theta is √2/3. That is your tan theta. You got this. Tan theta is √2/3. Okay. If tan theta is √2/3, then you will get sin theta also and cos theta also. So for example, sin theta is √2, and over this is √11 because P by B, so you got like this. So sin theta is square root of 2/11. That is sine of theta. Now let's see this way. That what actually you need. You need this one. You need now modulus of B. So modulus of B is here, right? Anything you can go from here. So B times sine theta, that is A, first of A. So modulus A is known again. Modulus A is known, that is √3. That's a good number. So that is √3 times B. Anything we can come. Then here, that is root of 2/11, and that equals √2. So √11 goes off. So B is simply √11/3, and that's your answer. This is fast. But then the drawback is that it does not give you B. It does not give you B. It just gives you modulus B. But that is what was required in exam. They didn't require you B. So keep your eyes open. If they want B, then this one. If they don't want B, then this one. Same as number one. That if they want D, of course I have to find. There is no other way. If they don't find D, then they don't need D. Then I can just find the CD. That is the projection length. I hope that is clear. Any doubt here? All right. I can see many participants. Some other names are also there. Okay. So this is this one. Number 4. Number 4 I will leave it to you to do. It is again same thing, that length of projection on the line segment. So you have got the plane. So you have got a plane. It is the same question. You have got this one. So most frequently asked question like that, A and B. So A and B I'll write as 5, -1, 4, and this is 4, -1, 3, and you want projection on this one, and that plane is given to be x plus y plus g equal to 7. I mean that this kind of thing, right? This kind of thing you want, this one. So as I told you that I will do like this, that this kind of thing. So I know this n I know. This n is 1, 1, 1. So I will just resolve along this one, and then I will use Pythagoras triplet. That's all. So I mean your answer will be L square. This is L that we know. So L square minus AB dot n and over n, and this is whole squared. This one. This will be your answer. If you can simplify it also if you need, but I think this works. This is more than enough, so we can do it. So this will give you correctly the answer. And if you do correctly fourth, then you should get the answer as I got. Fourth you should get as D as the answer. Be careful. They'll always give these kind of root 2 over 3, 2 over root 3, 2 over 3, 1 over 3. So if you do a single mistake, then you are gone. Fifth again is vector equation, just like the other thing we had there. But then you want u dot b is 14 modulus u square you want. So see, you a vector coplanar with vectors. Here some people start like this also, that let u equal to xi, or not xi, they start u as lambda a plus mu b. Means start that lambda times a plus mu times, because it is coplanar, right? So you can write lambda times a 2, 3, minus 1 plus mu times b, and then apply the condition that u is perpendicular to a, so u dot a is 0, to find some conditions, and u dot b is 24, so you can get this one. But this is not recommended. What is recommended is this: directly you write that a vector, this is a good result, a vector coplanar with a and b and perpendicular to a is given by, this is a vector, is given by a cross b. Means a cross b is a vector that is coplanar with a and b and perpendicular to a. See, this tells you whole story, a cross b. So this is a cross a, because it is perpendicular to a in the plane of a and b. So this is my starting point. So any such vector is this. So that is u, and u dot b is 24 will seal the fate that what it must be. So this u will be lambda times, so lambda times a cross a. So I'll write this is a dot b times a minus a dot a times b. So I'll get a dot b. Now a dot b, this is a, your a is 2, 3. I will avoid writing this one, and b, it is short, I will write like this. That is good for exam also. You write like this one, ordered triads. So a dot b, that is 3 and minus 1, 2. So a dot b is 2. So you are getting u equal to lambda times 2a and minus a dot ab. So a dot a, that is 9, 4 and 13. So this is 9, 4, 14. So 14 and times b, and that b is given to be 1, b is given to be 0, 1, 0, 1, 1. So this is lambda times, this is 2 I can take out. I can take out 2 also because I want just proportional, and this is a minus 7. So 2, 3, -1 minus 7, 0, 1, 1. So this will give you one vector. This will give you one vector. So I'll get this vector, right? So once I get this vector, then the moment I get this vector u, I can calculate then u dot b. U dot b is 24 is given. So from that I will get lambda. And after getting lambda, you will get your answer for modulus of u square. So is the method clear? Is the method clear? That you will get your answer like this. That you get u, so u is one vector, like you can calculate minus 5 another thing. And once you get that number, then you can have other thing also. So u dot b is 24 given, that will determine lambda. You can take 2 lambda in fact as mu, because why to carry 2 lambda? You can take directly a mu or some other constant. And so you will get this, and then you will get this answer. And if you check it, you should get 336, 336. That will tell you about this one. Now this kind of question will come again and again. Vector equation of plane passing through the line of intersection of planes and perpendicular to something, means one plane which is passing through the intersection of two planes, right? Means two planes are intersecting, and there is a third plane that contains this line. There are many such planes, right? This is one plane that contains this line. This is another plane. There can be still another plane. Still another plane. Lot of planes are there which contains these lines, which contains this yellow line. The intersection of plane pi 1 and pi 2. And the way you do with family of lines, what you get? You get pi 1 plus lambda pi 2. This happens to be pi. So many such problems relate to that. Is it clear? So many such problems relate to that, and you get pi 1 plus lambda pi 2. And if you get that pi 1 plus lambda pi 2, I can write this as, so let me write here only. We write x plus y plus g. We write x plus y plus g. X plus y plus g minus 1 plus lambda times 2x plus 3y plus 4g minus 5 equal to 0. And so I will get here 1 plus 2 lambda. I am writing only coefficient of x, 1 plus 2 lambda x plus 1 plus 3 lambda y plus 1 plus 4 lambda g and minus plus of minus 1 minus 5 lambda equal to 0. So this is the plane we are getting P. But given this plane is perpendicular to this plane, so it means that both normal will be perpendicular, normal. And so if this is n1 and this is n2, this vector n2, this is n2 means 1 minus 1 1. So n1 and n2, these two vectors are perpendicular, and so you will get n1 dot n2 is 0. This gives you lambda. This gives you lambda. This gives you lambda. Means you get 1 plus 2 lambda. You get 1 plus 2 lambda minus 1 minus 3 lambda and plus 1 plus 4 lambda is 0. And so you are getting 1 plus 3 lambda is 0. So you're getting lambda is negative 1 over 3. Once you get lambda, then your thing is done because you get the plane. So you get the plane. So you just have to write the plane in this form once you get that. So let me just write for you. So I got the plane as 1 plus 2 lambda. 1 plus 2 lambda x plus 1 plus 2 lambda x. And if you can check that, 1 plus 2 lambda x and 1 plus 3 lambda y. So 1 plus 2 lambda x plus 1 plus 3 lambda y and plus 1 plus 4 lambda g and then plus negative 1 minus 5 lambda is 0, and we get lambda is negative 1 over 3. So negative 1 over 3, so I can write 1 minus 2 over 3. I will write coefficient of x only, 1 minus 2 over 3 x plus 1 minus 3 over 3y plus 1 minus 4 over 3g plus minus 1 plus 5 over 3 equal to 0. So I will get x, and this is y times 0, so x times 0, and this is 3 minus 4, so this is minus g, and this is 3 minus 5 by 2, so this is plus 2 equals 0. So x minus g plus 2 is 0, and this equation only is written as r times, so r times and then xyg, so I will get I plus j and I plus 0 minus k plus 2 is 0. So we'll get r dot I minus k plus 2. So it is vector form. R dot minus k plus 2 is 0. So this is what you are getting. So this is what we'll write. I hope that is clear, that how we'll get that one. Okay, let's go to the next one. This theme we will return in a couple of problems, because that will be really interesting to watch out that these things have been asked always. Frequent theme. ABC belong to R and A square plus B plus C square equal to 1. So you want this one, angle between the vector, this one. Now, this is a question of trigonometry in fact. So angulating vector means that you can write cos of theta, cos of theta, cos of theta, not cos of theta is a given thing. So you have got angle between vectors. So angle between vectors is given by, say, write cos phi, cos phi. So cos phi is ai plus bj plus ck. So I will get ab plus bc plus ca over root a square plus b square plus c square times root a square plus b square plus c square. So you're getting just ab plus bc plus ca. Now rewrite this as, this is a vector equation, this is just trigo equation. Identity is basically one line, it is famous also. So write this as 1 by a by cos theta is 1 by b, don't write a, write 1 by b by cos of theta plus 2 pi by 3 is 1 by c by cos of theta plus 4 by 3. By ratio, this equals 1 by a plus 1 by b plus 1 by c, and upon add all of them, cos of theta plus 2 pi by 3 and plus cos of theta plus 4 pi by 3. Now those who have done their trigo, they know that this equals 0, but I will show it in one line. This proof is simple. So cos theta plus 2 pi over 3 plus cos theta plus 4. In fact, general also happens for if you write a multiple of 2 pi, right? So now cos theta. So cos theta you leave cos c plus cos d, 2 cos c plus d by 2. That will give you theta plus pi, because you will get 6 pi by 3 2 pi and half of that this one, and cos c minus d by 2. So that is 4 pi by 3. So 2 pi by 3 and y. So this is cos pi by 3. So this is cos theta. This is minus 2 cos theta. This is 1 by 2. So it is 0. So you get this number as 0. 1 by a plus 1 by b is 0. So if that is 0, if 1 by a, 1 by b, 1 by c is 0, this means that ab plus bc plus ca is 0. And so you can say that the angle between these two vectors is pi by 2. That should be plain to read, that pi by 2 will come. Is that clear? Next, let x naught be the point of local maxima. It's a question, it looks like a vector question, but just the tracing is vector. Other things are just relative maxima is to be found out. So first of all, you are writing that is a dot b cross c. So a dot b cross c is, you know, it is box product. So fx is abc box, and for that the notation is this, that you are writing x minus 2 3, b is minus 2x minus 1, and c is 7 minus 2x. This is what is ABC, right? So you can of course expand it along the rows. So I can write just x minus 2 3, and this you expand, I'll get x square plus 2. This is negative 7 plus 2x, and I will get 4 minus 7x, and I can just multiply. I'll get x square plus 2 plus 14 minus 4x and 312 minus 27x. So you will get here x cubed. We got here x cubed, and then x square you will get x square term, and no x term you are getting x term. So x square plus 2 is there. So you are getting negative 21, negative 20, negative 4, so 25, and then other terms you are getting. So if you do it correctly, you should get some answer. And so let me tell that what you will get for you. So x cube minus 27x plus 26. Just check this work first. So x cube minus 2x, x times x square plus 2, x times x square minus 2. I mean x square minus 2 here. So you will get minus 2x here. So minus 2x you will get. So now we are fine. So you will get 26 now. So this is f of x. So f of x is x cube minus plus 26. Now f prime x, 3x square minus 27. So that is 3 x square minus 9. So you'll get x minus 3 and x plus 3. This one. So this is one thing that they are saying, that local maxima minima. So you can find f double prime now. So that is routine question. 9x is there. So f double prime is positive at x equal to 3. So f double prime 3 is positive. And so you can find this value, a dot e, b dot c, c dot a. So once you find this one, then you have to just find these numbers, like a dot b plus b dot c plus c dot a dot. Or you can find this way also. One way, so this could be a dot b plus b dot c plus c dot a will be half, and here you've got a plus b plus c squared minus a squared b squared c squared. Does that make sense, this one? So you need not calculate all of them separately, a dot e, b dot c. You can just calculate sum of a plus b plus c and other things you can do. So you will get directly this one. And so these are easy to calculate. You will get the answer. And if you do the answer, if you do it correctly, you should get negative 22. Just check the answers later, because practice it is good. Let's come to 9th question. It is similar question, passing through the section of planes. So this is similar to 6. No, I mean 6, 9 and 15. Let me write here. These are similar. 15 also will come later on. So one already I have done. And in fact here, plane passing through of two planes. So what you are writing is that, okay, this plane, these two planes are given. So I write x plus 4y minus g plus 7 plus lambda times 3x plus y plus 5g minus 8 equal to 0. So I can write the plane. So I can write the plane as 1 plus 3 lambda x plus 4 plus lambda y plus minus 1 plus 5 lambda g plus 7 minus 8 lambda is 0. So we get like this. But this is the plane, and they are saying that the plane is this one. Means plane is ax plus by plus cg, 6g minus 15 equal to 0. Ratio must be same. So I can write 1 plus 3 lambda over a is negative of 4 plus lambda over b. This is negative 1 minus 5 plus 1 lambda upon c. Not 6, it is 6 given 6. These two are given 6. And 7 minus 8 lambda over 15. So this gives you lambda first. This gives you first lambda. So you get lambda using that. That is clear. You get first lambda. The moment you get lambda, after lambda what you can get? If you get lambda, then things are almost done, no? Because once you get lambda, then you get the plane. So lambda determines the plane. So lambda will determine the plane. So lambda get the plane, then plane. And once plane is there, then this is distance of point. So if plane is known and distance, that is distance formula that you can quickly use. No, that plane distance formula is there. No, that a alpha b beta c gamma upon that one, root a square b squared c squared, you can directly use, and this is a good formula, just like line. So this takes care of that. Let me go to next one. Shortest distance. This always people have problem in shortest distance. So shortest distance, let me do in detail. So shortest between these lines you want, line of planes. So first of all, this line also I will express in the form of symmetric form. So symmetric form. So what I write, that this is the line x plus y plus g plus 1 is 0, 2x minus y, 2x minus y plus g plus 3 is 0, right? So intersection of planes. So first of all, 1 1 1 direction is here, 1 1 1, here 2 minus 1 1. I have to cross it. Because once you cross it, you will get the normal to the plane. What will that be? That is 1 minus minus 1, 2, number 2, cross we are doing. And then here 2 minus 1, 1. And here negative 1 minus 2, which is negative 3. So you are getting 2 1 negative 3. Right? Just check that you are getting 2 1 negative 3. Correct? Just check the work that you are getting 2 1 negative 3. So 2 1 negative 3 are this one. So and then you can also find 1 point on the line. 1 point on the line. So you can put, say, g equal to 0. You can say put g equal to 0, x plus y equal to minus 1, 2x minus y equal to g equal to 0 minus 3. I can add them. 4x, 3x, 3x is minus 4, x is minus 4 over 3, and similarly y also you can use. So y also will use. So my answer, y becomes your x is negative 4 over 3, x is negative 4 over 3, and y also becomes 1 over 3, and one answer was given like to be 0, right? So what is the conclusion now? That there are two lines. So let's draw the two lines. One line is this, both are symmetrical form. One line this, one line is this. Is the screen okay? So let me refresh. Okay, sometime it may freeze, but then I think it's mostly all right. Let me check. Yes, I hope you can see me, right? That's all right now. No better. Okay, so you are getting this one. So let me draw the next. Let me draw the next page. Create a page. So you are getting this kind of thing, that you have got one point point is negative 4 by 3, 1 by 3, 0. Other point you are getting as 1 minus 1 0, because this was given point 1 minus 0. This direction ratio is negative 2 negative 1 3, and this direction ratio is 0 negative 1 1. This one. So now first of all I would like to find dr corresponding to this one, perpendicular normal. So that is cross minus 2 minus 1 3 L cross 0 minus 1 1 cross. So this cross I will write as minus 1 minus 3, that is 2. This is 2, and then this is 2. Then you come from here. So this is 3 minus 2, this is 2, and again here. So this also is 2. So this is 2 2 2 direction ratios, which I can write as 1 1 1, right? Which I write as 1 1 1. So it means now the question becomes that there are 2 points. This is 2 points. These two are 2 points. These two are 2 points. For me, this is 2 points. Yes, Akriti, can you see me? It's not freeze now, right? It's all right now. Is the screen all right? You can see me. Yes. So is it all right? Okay, so minus 4 by 3, 1 by 3, 0, and this is this one. So this AB, I want AB on this end. Looks to AB in end. So this AB is nothing but 7 by 3 minus 4 by 3 and 0. This is this one. And now distance you want on this one on n. So your 1 1 1. So your answer is 7 by 3 minus 4 by 3 plus 0, and upon root of 3. So you get 1 over root 3. This is your answer, 1 over root 3. So we got this one as the shortest distance between two lines. So one line given in symmetric form, one in general form. So first reduce it. First reduce. Yes, Satyam Soni, is the screen freezed? Or now it is working perfectly? Now it is working perfectly? Okay, now let me check this one. The vertices B and C of triangle ABC lie on the line such that BC is 5 units in the area of this one. Here again some other thing is there, right? Here you have got this ABC, right? ABC. This BC as given line is given. That BC passes not given, but BC, like coordinates of A are given 1 minus 1 2. This one, and BC is 5 units. And then how do you know these kind of things, right? So line is given, B and C like this line, means this line is point is minus 2 1 0, and this is 3 0 4, like that, 3 0 4, and this one. All right, okay. Akarti is saying all right, so I'm relieved that at least I'm visible. So this is 2 minus 3 1. So what I will do here, that on this line I want to find perpendicular. Now this is the thing, I want to find perpendicular. So it means my question is, because BC length I know, so that is that this point is 1 minus 1 2, this point is minus 2 1 0. I join this point, right? Minus 2 1 0, 1 minus 2. Let me write little more. This is minus 2 1 0. This is 1 minus 1 2. These are the points, 1 minus 1 2. Now what I'll do, that I will find this perpendicular. For that I can find the projection first, projection. And this I know, this I know, this direction I know, this direction I know, this direction is 3 0 4, 3 0 4 direction, and one perpendicular. So I can simply write that this is L square, this AB, this is A and B, not B, A and P, some point AP. So this AP point is AP vector is, say, 3 minus 2 2. This is AP vector, 3 minus 2 2. So AP vector I can resolve along that one, 3 minus 2 2. So let me resolve along this one and say that what you are getting. So 3 minus 2 minus 2. So this is 3 times 3 plus minus 2 times 0, that is 0, and plus 8, and resolve along this one you are resolving. So you are getting 3 square plus 5 square, so you are getting 5 root 5. So this is 5. So 5 you got. So this is 17 over 5. This is this one, 17 over 5. That is your projection. So this is length is 17 over 5. But you want this one, right? You want this one. So that height will be, so that h square or h will be 17 squared, because we know this one, not 17, only 17. H square is only 17 because mod AB is root 7. Mod AP is root 17. Mod AP not root 17 minus 17 by 5 whole square. So 17 into 1 minus 17 upon 25. So 17 by 25 and times 8. This one. So you got 17 by 25 times 8. This is good. So you are getting here this length perpendicular. So this is root 17 by 5 by 2 root 2. This is 1 root 17. And then you can also have this one. No, you can also have this one that already you know. So I can write this 2 by 5 times root 34. But you know base, so area will be, so you know that area is half into base into height. So that way I will get half into base is 5. Base is 5, and then you're getting 2 root 34 by 5. So you will get root 34. So that is how it will get. Correct. Again, a tricky question, but then done easily using vector language. So this is about 11. 12. ABC is right angle triangle, and position vectors of ABC are given. Then point PQ lies on a line. So ABC are the position vectors. So what we know from it? Right angle vertex A. So right angle vertex A. So vertex A I can write vertex A. Vertex is 3i. So I will write 3 1 minus 1. B is minus 1 3p, and C is 5q minus 4, right? This will write 5q minus 4. Please note that make use of perpendicular criterion, that ABAC are perpendicular. ABAC are perpendicular. What does that give you? If they are perpendicular means I can write direction cosine. I can write AB dot AC is 0. So that is 3 minus 1 4. I, or write just 4 the vector. So write 4, 3 minus 1 4. This is 1 minus 3 minus 2. This is minus 1 minus p, and dot AC. Now AC is minus 2. 1 minus 9 is minus 8, and minus 1 minus 7 is 5. So dot this one is 0. This one dot is 0. Then from there you will get some value, right? You will get the value of this one, because you are given that this is 90 degrees, so you get some value from here. What is the value you get? Can someone tell that what value they got? Can someone tell what value they got for 12? You will just simple equation, right? So you'll get 3p minus 2q as I got, plus 13 is 0. You got 3p minus 2q plus 13 is 0. So it tells you that it lies in a plane, not this one, plane. And then plane makes an acute angle with positive direction. That is clear, because positive negative is there. The way we distinguish in 2D, same in 3D. So we got this one. So makes an acute angle with this one. That is about 12. Let's come to 13. 13 is based on triple product. So you know that property that UVW is VWU UVW, just like ABC. So UVW WVU VUW. Correct. Cyclic. UV and W. Let me write here. So this is U cross UVW, not this is UVW. So that tells you that cyclic order UVW is VUW, UVW is VWU is WUV. So they are the same numbers given. Right? So 3p square comes out. And times UVW comes out. Minus PQ comes out and VWU comes out. But this is same. Again here minus 2q square comes out. So you are saying that 3p square minus PQ, 3p square you are getting. Just check what you are getting. 3p square minus PQ plus 2q square is 0. This you are getting. Now the question says that how many values it has. What is your guess? How many values it has? You will show that there is just one value. P and Q both 0 0. People may think infinite or something, but no, only one value. Both P and Q must be 0. PQ of course are real numbers given also, and it must be, otherwise there is no meaning. So here I can say this way, that suppose Q is 0, then P equal to 0. So assume Q is not 0. Then I can write 3 times T square minus T plus 2 is 0, where T is P by Q, right? Q is not 0. But discriminant of this equation is B square minus 4AC, that is negative, and so T can't be real. But P and Q are real, so T has to be real, right? So contradiction achieved. So you can say that okay, this is nothing value. So only possible value is PQ, exactly value of PQ, and that value is given by 0 0. Origin 0 0. So you will get that. Okay. This is more geometrical argument, that you are given ABCD parallelogram such that AB is Q. So let's make a fair diagram that you have got this A, and R is the vector that coincides with altitude from B. So this is AB CD, and you want from B, you want altitude directed towards him. So this you want. This is your AB. Right? So AB is given to be Q, and AD is given to be P, right? This is P and Q, AD, P and Q. You want this one. So this is actually what you can write. This is first of all projection, right? We did it again in other problem, right? If you remember correctly. We did in projection problem. Is that clear? Yes, class. Is that clear? We did in projection problem. So Q. So projection of Q along this ADP. So that is your AX. Suppose AX. That AX vector is Q dot P upon P times P, right? Upon P is modulo. See AX. And see AX plus XB. AX plus XB is Q. But XB is given this one. BX is odd. So I can write AX means Q dot P upon PP and minus R equal to Q. So R is Q plus this one, right? So you will get that this kind of answer, that this answer will be B. R will be minus Q plus, right? R will be minus Q plus is, right? See, we got first AX now, and we are saying that AX plus XB, we are using AX plus XB equal to AB. So be careful, you cannot write AB in full form. So you will, AB is already Q because given, AB is Q given. So you will say that this Q, you will say that okay, this Q is made up of AX and XB out of XB given, so you can find this number. So B you will get as the answer. This is the next one. Again same thing, this we have done already, plane containing the line and parallel to. This time again plane containing the line. So again same thing, that there is some line, and so many plane will contain it. Then problem would be over, right? But then we are saying that no, we want parallel to the plane. So it means first we will write that any plane is 2x minus 5y plus g minus 3 plus lambda times x plus y minus 5, this one. This plane is parallel, so I can write here as 2 plus, I can write this as 2x, so 2 plus lambda x plus y. Y I can write as minus 5 plus lambda y, and plus g. G I can write as 1 plus 4 lambda, and minus, you are getting this one, this whole thing, minus, say this is 3 and 5, so minus plus of minus 3 minus 5 lambda equal to 0, this one. And parallel to the plane means this must be same, DRs must be same, so it is proportional. So 2 plus lambda upon 1, you have to find a perpendicular and parallel. Perpendicular means dot is 0, parallel means that they are just the multiple of each other. So I'll write this 2 plus lambda by 1, 2 plus lambda by 1 minus 5 plus lambda upon say 3 and 1 plus 5 lambda upon 6. You can find lambda from here and you can check that indeed you are getting, because we have assumed parallel to the plane. It may not be parallel, so it is indeed parallel to this plane. So we'll get this one, and if you this one, then you will get A as the answer. The way I got, you'll get A as the answer. Again some sort of distance. So here this is 1 point, you want distance of 1 minus 5 9. You want distance of 1 minus 5 9. You want distance of 1 minus 5 9. This distance you want measured parallel to this one. No, if you don't write anything, then it is always perpendicular distance. If I don't write, it is always perpendicular distance. But I am writing now. So if I am writing, it means that this becomes, let's check it, that this becomes this distance. This is A, this is suppose A prime put perpendicular, and this is suppose B. So you want AB now, AB along the line. So this you write as 1 1 1 1 1 1 direction ratio along the line you want, and plane is already there. So you can take this as x minus 1 by 1, y plus 5 by 1 is g minus 9 by 1 is t. This we can, so you get t plus 1, 2t plus 5, and t plus 9. This one 2t minus 5. Now this this lies on this line. So you get this plane. So t plus 1 minus, because you can find b then, okay, measured parallel. So t plus 1, let me write this, that we got this one, x minus 1 upon 1, 1 1 1, x y plus y upon 1, and g minus 9 upon 1 is t. So x is t plus 1, y is your t minus 5, and g is t plus 9. Is that clear? T plus 9. So this is b, and it lies on where? It lies on this line. It lies on this plane. It lies on this plane, x minus y. So t plus 1 minus t minus 5 plus t plus 9 equal to 5. So you can find t from here. The moment you find t, then you can find b. Already it is given. So if you find t and b, then you can have the answer that, okay, you will find the point b, and you want ab only. So already t is there. So your answer for ab will be t times root of 3. T times root of 3. Correct? This is important. Not t by root 3. Not t by root 3. This is t times root 3. Because that way you will have much more thing coming up. And so if you do that, you should get 10 root 3. 16d you will get. 17, again, good question. Bisects the angle between b and c. But then we do not know it is internal external bisector, right? So what I will do, that I will say that, okay, bisector, any bisector is b cap minus c cap or b cap plus c cap. It depends, because they just said bisector, and moreover 2 is there, so it won't come always, right? So this is b unit vector. So b unit vector b is 1/3 of, no, 1 by root 2 of 1 comma 1. C unit vector is 1 by root 18 of 1 minus 1 4, this one, b and c, and bisect. So b and c, so I can write here b plus c. If I write b cap plus c cap, you see I'll get 1 by root 2 1 1, let me write 0, and 1 by root 18 1 minus 1 and 4, 1 minus 1 and 4. So I can take common. So root 2 you forget, because you want anyway one parallel vector. So multiply this by 3. So you work with 3 times 1 1 0 and plus 1 minus 1 4. So that is 3 3 0 and plus 1 minus 1 4. So we'll get 4 2 4 2 4, 1 1 minus 4, 4 2 4, and 4 2 4. I can again write this as 1 1 and 2. So this is b plus c, right? So b plus c did not give you the answer, right? So maybe you can check b minus c now, and you will find that b minus c will of course be working. 4 2 4 is there. So this is actually 2 1 2. This is not, this is actually 2 1 2. This is actually, that you be careful about the mistakes. So this is 2 1 2, this one. If you write b cap minus c cap, then probably that should give you the answer. So let me check. This is you right, because you see 2 is there. B cap minus c cap. So it is 3 times 1 1 0, 3 times 1 1 0 minus 1 minus 1 4. So 3 times 1. So this is 3 minus 1 2. This is 4, and this is 2 4 and 7, I think. Just check this one, that what you are getting. 3 minus 1, 3 minus, let me do again. This is b minus c cap. So you are getting 3 times 1 1 0, 3 times 1 1 0, and minus you will get 1 minus 1 4. So you are getting 3 minus 1 2, and this is 3. So this is 4 2 4, and this is 3, and no, this is 0, this is minus 4. And if you write here that 2 you take out, so you'll get 1 2 minus 2. So you get that one. So you get beta, you get alpha, you get, and then from there you can calculate, you can say that what you are getting. Okay, this is all right. 17. So 17 answer, let me tell you the answer. That 17 answer was that if I got it A. 18 is one lemma we can use, that I can say that if lambda A plus mu B plus nu C is 0, then we can write that B cross C over lambda, C cross C over mu, and mu cross mu, not mu cross, A cross B, B cross C. So if this is 0, we'll get A cross B upon, sorry, start from B cross C. You will get B cross C over lambda is C cross A over mu, and A cross B over nu. This will get lambda mu nu. And this I can add it also, because it is just like ratio proportion. I can write B cross C plus C cross A plus A cross B upon lambda plus mu plus nu. This one. So at you see, this is all 1 1 1 you will get, right? 1 1 1. If for this particular problem, because all are 1, you will get B plus C by 1, C cross A by 1, A cross B by 1. So that is A cross B, B cross C cross A by 3. So this number, this 3, this one, this will be given by 3 times any cyclic order. So A cross B. So 3 A cross B matches here. And out of these two, you can check always that what you are getting. That you can get easily. So that you can check like this, that you will write A plus B plus C squared. You will get A squared B squared C squared plus twice A dot B, B dot C, C dot A. So A plus B plus C squared is 0, right? And this is 3. So you are getting A dot B plus B dot C plus C dot A is negative 3 over 2. So again you get negative 3 over 2. Any doubt here? So you will get C as the answer. For 18 you will get answer as C. The answer is C. Let us go to the next one. 19 is again solving. So I can write 19 is vector equation solving. So I can write B cross C minus A equal to 0. That is, B is parallel to C minus A, or conversely, so C minus A equal to lambda times B. That is your statement from here, that B cross C minus A is 0, so C minus A is parallel to B, so C is this one. So I can write C is A plus lambda B. Already given A dot C 0, so I can write here A dot C is A square plus lambda A dot B. And so A dot C is 0, A square plus lambda A dot B. So A square is your 6 and plus lambda times A dot B, and A dot B, if you write A dot B is 1, A dot B, I is there, so 1, and this is plus 2 and 3. So A dot B is 6. So you are getting 6 plus 6 lambda. So lambda you are getting minus 1. Lambda you are getting minus 1. 6 plus 4, no, you're getting 6 plus 4 lambda, in fact, right? You are in fact getting 6 and plus lambda times A dot B. So A dot B, you are getting one sign is 1, I minus 2j plus k, and I minus j plus k. So you are getting 1 plus 2 plus 1. So you are getting 4. So you are getting 4.